I would suggest to go to the web and find out the spectra of the halogen lamp and determine the temperature using this equation. Okay, let's look at the second aspect of this experiment. Experiment तो बहुत आसान है, आप 3 मिनट में ख़त्म कर लेंगे, लेकिन you need to understand the theory जिस purpose के लिए हम कर रहे हैं. Now let's look at the Planck's radiation law. You have already studied many times कि there is a relation given in terms of the wavelength. So Planck's radiation law gives us the whole spectrum of the black body radiation, which covers from the very short wavelengths to the very long wavelengths as well, and the total power is actually integration of this area which we get. But how we get the temperature of this radiating body is, what we do is we want to find out the peak, where the peak is, and you look at that at peak. If you want to find out a peak of in any curve, what you do is you differentiate and equate it to 0, because at this point the slope of this function should be 0. तो इस distribution function को differentiate करेंगे, equal to 0 करेंगे, simple mathematics करेंगे, we get to this equation. This equation cannot further be solved analytically, तो इसको numerically solve किया जाता है. So B की value यहाँ पे hc over kt है. So we have got a solution on this side and solution on this side as well. जब जब दोनों converge करेंगे किसी एक point के ऊपर, तो वो इस equation का solution होगा. तो वहाँ वो जो the converging point gives us this value 0.2015. ये हमारे पास Wien's law equation आ गई है. This is Wien's displacement law, which relates the temperature with the peak of the radiation spectra. So you can use this one to determine the temperature of the radiation body. ये मैंने अब आप जब experiment करेंगे, we are using tungsten halogen lamp. Tungsten halogen lamp का जो peak आती है ना, वो infrared में है. Unfortunately, we don't have spectrometer जो कि पूरा spectrum catch करे. I would suggest to go to the web and find out the spectra of the halogen lamp and determine the temperature using this equation, and compare it the one which you have calculated using the electrical power and then using the Stephan-Boltzmann. यहाँ पे displacement law की we have tried to sketch it. You look at that for 4 different temperatures, the radiation spectrum is different. So जितना temperature कम होगा उतनी broad peak होगी और उसकी peak intensity कम होगी. But as the temperature increases, the peak becomes sharp and it shifts towards the shorter wavelengths. So look at these 4 curves actually represented for 4 different temperatures, T1, T2, T3, T4. इसी तरह ये इसका बहुत आसान एक्सपेरिमेंट है. घर में हमारे पास टंगस्टन फिलामेंट बल्ब होता है ना, किसी तरह उसको वेरिएबल रेजिस्टेंस के साथ लगा लेना, and you change the current flowing through that one. You can see the colors, emission spectra का जो है वो starting from reddish to yellowish, and when it's fully hot thermal equilibrium तो आपको bright spot मिलता है. तो उस वक्त वो सारे के सारे visible में जो colors हैं ना वो emit हो रहे होते हैं, because the temperature is increasing and then at thermal equilibrium temperature becomes constant. यही वाले इस experiment में we switch on and we leave it for some time so that कि वो थर्मल इक्विलिब्रियम आ जाए, फिर उसके बाद स्पेक्ट्रम शिफ्ट नहीं आएगी, उसके अंदर स्पेक्ट्रल शिफ्ट नहीं आएगी. अच्छा, अब हम लेट्स गो टुवर्ड्स एक्सपेरिमेंट. इन द फर्स्ट पार्ट आई विल शो यू व्हाट पार्ट्स कंपोनेंट्स ऑफ दिस एक्सपेरिमेंट आर, एंड देन वी डू द मेजरमेंट्स. Once we have done the measurement, we'll come back and we will summarize कि आपने काम क्या करना है उस डेटा के साथ and what you have to prove.